Good morning. Today we are going to see the composite functions, right? I don't want to talk about much about this, right? You all have done in your O level, in the AS level. We have done come across so many questions, blah 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 blah, a lot, right? So anyhow, right? The composite function in the sense two or more functions combine to make a new function, right? Very simple. Two or more function combine together make more function or new function is composite function. For example, function is like g into gx. A function of x in g is gives you a gx, right? Then this is given a function of f is going to be f into g into x. So okay, so this is another way you can say from here to here f into g into x. Straight away also, first what you will do, the second function you substitute first, then you write. Oh, now you all have enough experience to do this. I know that you all can do any amount of these composite questions. I don't have any problem with you all. So any fgx or function g into hx or something like that, right? So but we have to understand certain things in that, right? F into gx means apply g first, right? F into, first we apply gx, and gx is the x for the function of x. Okay. Another one more thing is most important and confusion thing. F into gx is equal to f into, or the bracket g into x. This is equal to this, but not equal to g into fx. Sometimes it comes, but mostly it's not so true, right? It's sometimes maybe chances, but not always, right? Okay, but you can't give as a condition, but it's not in this, right? Okay, so the composite function is we can do straight away. I can go to explain. Some of the examples is enough for you all to do, I hope. So in this when come to the questions, right? Okay, I hope it's okay, right? When two or more function to be combined to make a new function is known as composite function. Then first you will apply the gx, then you substitute on the fn. So either gx then applied on the fx you get, or straight away also we can do, you know, both the ways I have done with you all in the classes and things like that. So I hope it's easy for you all, right? So I'm going to do some questions. Right. So they are given given fx is equal to, example, fx is equal to 1. So x squared, and gx is equal to x plus 1. Okay. So first they are asking to find a part. They are asking to find f into g into 1. Right. So first we have to find the f into gx. Then we can do this. So we know that f into gx is the function. I substitute now. This is the function for this, so it's going to be x plus 1 all the squared. So now when we come to this thing, f into g into 1 is going to be 1 plus 1 all the squared. It's going to be 4. Second part, these are very simple, but I need to do as a process. I need to take this and upload. So g into f into 3. So you know that g into fx we have to find first. So straight away I'm doing gx, right? X squared plus 1. Are you okay with that? Okay. X squared is going to be that. That is going to be gx, x squared plus 1. Right? So when x squared plus 1 in the sense, you get it that 3 in the sense, right? 9 plus 1 is going to be g into f into 3. Going to be 3 squared plus 1 is going to be 10. Am I correct? Right? So next what they want in the sense, f into minus 2. F minus 2. So here what you will do in fx, right? So then x squared, again x squared, so it's going to be x to the power 4, or else x squared to the power minus 2 in the sense it's going to be f into x squared. So this is going to be x squared, and again that's mean x squared to the power 2, x to the power 4 you can say. So f into minus 2 is going to be minus 2 to the power 4, it's going to be 16. Straight away you can write. Okay, so it's very simple question. I know it's no point of doing this also, right, for you all. So we can go to the another example, right, where they are given a question, right? Function is defined by fx is equal to 3x plus 2 and gx is equal to, right, x squared plus 4, right? So then first thing, the function of f into gx, a part they are asking f into g into x. Okay, so we know that it's not a difficult thing. So gx is going to be this in the sense, right? 3 into x squared plus 4 plus 2. When you substitute 3x squared plus 12 plus 2 is going to be 14. Done. Next one, b part. Right? So g into fx, right? G into fx, right? So gx, you're going to substitute on this. So in 3x plus 2 squared plus 4, when you open this, 9x squared plus 3 to a 6, 6 into 2 is 12x plus 4 plus 4. It's going to be 9x squared plus 12x plus 8. Right? 9x squared plus 12x into plus 8. Next, they are asking to find the value of f squared x. F squared x. So it's like f into fx. So then fx is going to be function in that. That means 3 into 3x plus 2 plus 2. It's going to be 9x plus 3 to 6 plus 2. It's going to be 9x plus 8. The last one they are asking the value of, right, they are given fourth one, f into g into b is equal to 62 it seems. Find the value of b. Right? F into gx is going to be, so 3b squared plus 14 is going to be 62. From that you get 3b squared is going to be 62 minus 14, you get 48. Divide by 3, you get b squared is equal to 16, therefore b is equal to 4. Right? We get it, b is equal to 4. Right? So this is also one of another easiest question, right, they have asked. So first I can find the composite, then straight away I'm doing, guys. I hope you all can understand this and you all can do it, right? Nothing is difficult for you all here. Then I'll do another question, right? So it will be bit coming with the function fx 2x minus 8 mod, then gx is going to be x plus 1 over 2, right? So first they are asking to find the f g into 3, right? So I'm going f into g into 3. So fx, where you're going to substitute f into g into x, right? 2 into, right? You will find that 2 into, right? So limit mod this then. For x, what you will do? X plus 1 over 2 minus 8, the mod. 2 and 2 cancel off. It's going to be x minus 7 is the mod. Right? X minus 7 is going to be the mod value over the whatever it is, like you get it, right? So in this, when you substitute 3, right, f into g into 3 is going to be 3 minus 7, it's going to be minus 4, mod is going to be 4, right? Then the b part, they are asking to calculate, right? Solve fgx is equal to b part, f into g into x is equal to x, it seems. So first I have to solve them, right? So f into gx is going to be x minus 7. So x minus 7, right? X minus 7 is going to be x, right? So when you want to solve it, then we know that minus into x minus 7 is going to be x. So 2x is going to be 7, x is going to be 3.5, right? So we can solve it. If they ask you to represent in the graph, right, I'll draw you with the graph. So y and x. So y is equal to x, it goes through this. So y is equal to x. Other one is going to be x minus 7 is going to be the graph. So then we are going to be, right, it's in another color, right? It's going to be 0, minus 7. So then we reflect that. It's going to be 0, 7, right? So this is going to be mod of x, it's going to be graph of x minus 7 is going to be y. Right. So if you are representing the graph, you can find it will be having only one value of one intersection, right? So we know the reason, so it's definitely it goes away from that. So only one place, so one solution will be there. That is what you get, is only one solution. Okay guys, so this I hope that it's not a difficult thing, right? Then when come to the inverse function, right? Inverse function also you all know that things, how that it works and things like that, right? So almost you all have done that in O level, AS, everywhere you have come across that. So it's easy for me to explain for you all and teach you all. Inverse function. The inverse function, in the sense, a function of fx and f dash x are inverse. So when you are given a function of fx, if you want inverse, it's going to be f dash x is the inverse function of this, right? Or else backward of function. For example, 3x plus 2, in the sense you get x multiplied by 3, then 3x, then plus 2, 3x plus 2. So backward, what you will do in the sense here, 3x plus 2 minus 2, 3x divided by 3x. So this is inverse of that. If you the map diagram of arrow version, you can write like this, right? Straight away, or else we know that 3x plus 2 is equal to y. Then you will make subject y. 3x is equal to y minus 2. X is equal to y minus 2 over 3. Therefore, you get f inverse x is going to be x minus 2 over 3. Either way you can write, both same. So you can see opposite of this or either way. Right? So it's very simple for you all to understand, right? If you are given a question to do that, right? If you are given a question, also you'll know how to do that, right? That's not a problem for you all, right? I'll do it straight away an example. So find the inverse function of fx is going to be 3 over x minus 1, right? X is our real value, right? All the elements are real, and x is equal to not equal to 1. By changing the subject of the formula, you can rearrange. Either way you can do it. We'll see, right? Okay. So what I can do is going to be let 3 over x minus 1 is equal to y. So 3 over y is going to be x minus 1. So x is going to be 3 over y plus 1. So when you are writing, inverse of x is going to be 3 over x plus 1, or else 3 plus x over x also. Both same. You all know, guys, I don't need to explain all those stuffs, right? Okay. When they wanted to find inverse of 1 or inverse of 4 or something like that, for example, if they have given, if you want to find inverse of 4, then you will say 3 plus 4 over 4, 7 over 4 you will write. Either any value is given, you'll know that to do that, right? Okay. So some different ways of function, that's mean how you will do and all those things. The function fx is defined by square root of x minus 2. State the range of fx. So then what you will do, the range of fx is equal to greater, y is equal to greater equal to 0, because you don't get the negative value for the inverse inside the bracket, so you don't get that. So another one I'll do it little bit, right? So fx is equal to square root of x minus 2, right? First sketch the range of, state the range of value. So a part, range, so in this square root is coming, so all the values of fx is y should be greater than 0. The range of fx is y is real, so y is going to be all real values, therefore y should be greater equal to 0, or else you can say fx is equal to greater equal to 0. All the values are going to be the range. Negative values cannot be because inside the square root. Next one, sketch fx is x and f inverse and the line. So they are given. Find the function f inverse. So B part they are asking f inverse x, right? F inverse in the sense we know, let y is equal to x minus 2 square root. So it's going to be y square is going to be x minus 2. So y square plus 2 is going to be x. Therefore, inverse of x is going to be, right, x square plus 2 is going to be the inverse, right? The inverse function f inverse is going to be x squared plus 2, where the domain of f inverse x is going to be a real value, so x is going to be greater than 0. The range of f inverse also, it's going to be y is going to be greater equal to 2. When you substitute on this, whatever, when it's 0, it's going to be 2. So greater equal to y is, when x is equal to 0, it's going to be 0, 2. So the range will be, right, domain will be, definitely for the inverse of domain is going to be, x is going to domain, x is equal to greater equal to 0. Range is going to be, definitely y is going to be greater equal to, when it's 0 applied 2, so 2 is going to be the minimum value. Above all the value is going to be satisfied as the range. Whatever the value, substitute 1 in the sense 3, 2 in the sense 4 plus 6, then it's going to be 3 in the sense 9 plus 2, 11, something like that. I don't want to do it and show you all those things, right? Okay. Next they are asking, sketch y is equal to fx and sketch y is equal to fx, third part or BC part, right? Sketch y is equal to fx and y inverse fx, y is equal to f inverse x and y is equal to x, right? So, and the line y is equal to x, right? We know when y is equal to x in the sense only that we are going to draw the positive part, right? Y is equal to fx is going to be all the real value. We understood that from there, right? I read this, right? So this is the graph going to be y and x. So this is going to be y is equal to x. So y is going to be x graph, right? When inverse x is going to be, all the values of y is going to be greater than 0. So it's going to be inverse of that, right? So x is also when, yes, when x is equal to 0, it also gives you when function of fx is going to be y is equal to real value. So y is 0 and above, right? So it's going to be when it is 0 in the sense, right? It gives you y is equal to 0 in the sense x is equal to 2, right? Y is equal to 0 in the sense x is going to be 2. So it comes like this. So it's going to be y is equal to square root of minus x. Same time you will get the graph for other one. The inverse is going to be y is equal to greater than 2. So then it's going to be here, it's going to be 2 comma 0. Okay. Then the other way also it's going to come. It's going to be 2. So it's going to like this, right? This is also 2 comma 0, right? So this is going to be the symmetry of the line where it comes and join. Actually it comes like almost, it comes like this and as well as like this. My drawings are not perfect. Okay, I hope it will, right? This will be y is equal to f dash x. That's mean it's going to be y x squared plus 2. It's going to be x squared plus 2. When x is equal to 0, it's going to be 2. It goes that. Okay. So this is how that composite function and inverse function, right? I'll be uploading those questions also. Then another one is going to be the graph, then limit, mode, and things like that. It's another one. The combining transformation is another one more thing. So after that we'll be completing this chapter fully, right? Then we'll go to the trigonometrical functions in next. That's also another interesting thing. You're allowed to do that, right, guys? So hope things are okay, right? So we'll meet up on next Zoom classes. Thank you very much, guys.